Okay, now we need to start talking about Bruno. We've been saying, oh yeah, except for the transition metals, don't worry about the transition metals. Now we're talking about the transition metals. So here's the deal with the transition metals, that all transition metals begin with two valence electrons. All transition metals begin with two valence electrons because if they're in the D block, right, in particular we're talking about the D block, the aluminum, gallium, indium, those are all in the +3 underneath aluminum. So we're just talking about the D block metals. They all start with two valence electrons because the only S and P electrons they have are the S electrons over on the left. Did you guys follow me there? Okay. Okay. However, they all can pull from the third level. No, I don't want to say third level. From the lower level. D sublevel, the D sublevel electrons. And this is what allows, this allows these metals to have more than one ionic charge, right? They can be a +2, or they can be a +3, or they can be a +2 and a +4, or they can be +2, a +3, and a +5. Some of them have up to 7. Some of them have up to 7 ionic charges that they can have, right? And it just depends on their chemical reaction. These are called oxidation states. These are called oxidation states. They have multiple oxidation states. Okay. So when you see a transition metal in a compound, okay, you have to use the crisscross method, or you have to use some logic to deduct what the charge on it actually is. So let's do an example here. Oh, did I really scroll that far down? Holy smoke. All right. So we need to deduce from the compound itself. Okay, so a couple of examples. The first one, and both of these are actual compounds. The first one is FeO, and the other one is Fe2O3. So from crisscross method, right, we can determine, this one's easy, right? We know that this goes up here and gives that a +3, and this comes up here and gives that a -2. And so the two ions here are Fe3+ and O2-. Right, we're good here? Okay. What about the other one? Because this is an iron with a +3 charge. Well, what is the charge on an oxygen? You should be able to look at the periodic table, see that oxygen is up there at it's atomic number 8. It's 2 spots away from our neon. And so it's going to have a -2 charge. Okay, in fact, and 2-, -2, same thing. In fact, if there's one of them that you guys need to memorize, it's oxygen. Oxygen, the -2, it is one of the most commonly, we use it as an example all the time. It is one of the most commonly used elements in compounds. So just memorize oxygen is a -2 charge. But there's only one iron attached to it. And so if the charges have to balance, that means this iron has to be a +2. Right? Now, if we were to name these would both be called iron oxide. Iron, obviously, from the iron, Fe, okay, and oxide from the oxygen. However, we can't tell which one of these we have from the name, because they're both iron oxides, but we haven't disambiguated which one is which. So we have a system for that. And into the name, we write the charge of the cation we're using. So the name for this over here, for this one, is iron, Roman numeral 2, oxide. Why Roman numeral 2? Because that's the charge. Does this mean we used 2 iron atoms in the formula? No, it means that the cation we used, okay, is the iron 2 cation. As opposed to the other one would be, what would be the name of the other one then? Iron 3, okay, because that is the cation, okay, for this compound. So that would be iron 3 oxide. Yeah? Okay, so we're going to practice a couple. No, that's not, Okay, so our next example is SnO2 for versus SnCl2. Okay, so I want you guys to find the oxidation state, or find the ionic charge on the tin. Tin is Sn. The easier one is here. Okay, chlorine, you can find chlorine. Chlorine's a halogen, so it's going to have what charge? It's going to have a Cl minus. There's two of them, which means this tin has to have what charge? There's two negative ones. There's only one tin, so this needs to be what charge? Positive 2, because we have two Cls, right? Two negatives, two positives. Okay. The other one is where this gets a little tricky. There's two oxygens here. Does that mean we have a +2 charge on the tin? No, it does not. What is the charge on one oxygen? Right, this is one we're supposed to memorize, right? -2. How many oxygens do we have on our tin? We have 2 of them, which means the tin must have what charge? +4. That happens. That is a real thing. Okay? Even to the point where there is actually a really nasty heavy metal that can get into the water supply. Okay, and it is called hexavalent chromium. And it's when chromium makes a +6 charge. Right? Well, look where chromium is. Chromium is number 24 up there. Right? 1, 2, 3, 4. Yep. You see it? Okay. Where did that +6 come from? Well, it loses its 2 s electrons, and it loses all 4 of its d electrons. You see that? It's the 6th one over. So to make the +6 charge, it strips everything away, and it looks like argon as a noble gas, but it even strips away the d electrons that are in the 3rd energy level. Okay, so that's where they come from. That's where these other charges come from for our transition metals, is that they lose other electrons in that d sublevel that's right beneath the 4s. Yeah? Okay. This then would be called, this over here would be called tin. Okay. And what's in the parentheses? Okay. What's the charge on the tin? The charge on the tin is +2. This is a Roman numeral 2. So this would be, let's get rid of the, okay, larger. Interesting. Okay. So this is going to be tin. Okay. It needs a Roman numeral. What Roman numeral goes here? Okay. It is this many, but what's the Roman numeral that goes there? You guys remember your Roman numerals? No. 1, 2, 3, 4. No, not 4. Oh my gosh. Black. Erase. Switch. Red. IV. And then 5. And then 6. Right? Remember, if the 1 is before the, right? If the 1 is before, then it subtracts. If it's after, then it adds. Yeah. Okay. So like this year. Welcome to MMXXIV. VI. Dang it. Yeah. MMXXVI. Yeah. That's this year. 2026. V's?
Yeah.
You have to know that that's 1, 2, 3, 4, 5, and 6. Yes. You shouldn't have to memorize them. You should know how to figure them out. Know the rules. It's easier if you know the rules. Okay. So each single one is 1. So there's 3. Okay. But when you start getting closer to the next bump up, which is like at a 5 and then a 10 and then a 50 is the next bump up, then if you put a 1 in front of it, it subtracts, right? So that the 1 in front of the V is a 4. So V is 5. A 1 in front means you subtract it, and a 1 after means you add.
Okay. Oh, that makes more sense.
Yeah. And so that would be 9. X is 10.
X is 10. V5, X is 10. With the ones in front, you subtract. With the ones in back, you add.
Yep.
I
I don't know why. Okay, so that's it for transition metals. Okay, but we now need to get into names. Okay, so the next part of this is naming ions. Okay, so first rule. Okay, they are always cation, anion. The first name is the positive charge. The second name is the negative charge. Okay. Most of the things that you just did in your previous lecture in the polyatomic ions were anions. Okay, polyatomic ions are almost always negative charged ions. Okay, there's only a couple of positively charged polyatomic ions. All right, names are always cation, anion. 2. Cations are just the name of the metal. Okay, except when they're transition metals, which is what we just covered. Then they are name and the charge in Roman numerals. Again, what do we put in Roman numerals? We put the charge of the ion, not how many there are. Yeah? Okay. So I want to go back up for a second into the shoot. I want to go a little higher. Okay. So here's a new compound. This compound has 3 calciums on it. So, do I call this something I screwed up in my settings? All right. Is the name of this calcium 3 nitride, calcium 2 nitride, or just calcium nitride? Well, I'll tell you. For a rhetorical question. Okay. It's not calcium 3 nitride. The Roman numeral 3 does not mean the number of calcium atoms. Those are not the same. Okay. Calcium 2 nitride is a possibility because the charge on this calcium, based on the crisscross method, is +2. Okay, so this is a possibility. However, it's also not the answer. Calcium is not a transition metal. Calcium is an alkali earth metal. It's number 20. It's over in the blues, right? It's in the S2 column, right? Therefore, you don't use a Roman numeral for it because it doesn't have a different ionic charge. We only use them for transition metals when they have a separate ionic charge. That make sense? Okay, so the conditions for using the Roman numerals are transition metals when they have a different ionic charge. Okay, and I'll tell you right now, take a look at zinc up there, number 30, right next to gallium. Zinc only makes a +2, even though it's a transition metal. Okay, because it has all 10 of its 3D electrons. It doesn't like to give those up. That's a very stable thing. It never ever gives those up, so it just loses its 2 valence electrons. Electrons 19 and 20. Okay. Must be transition. Must have more than one oxidation state. Okay. Except for in the transition metals, then his name is name charge. If, okay. 3. Okay. Anions are just the name of the nonmetal with the suffix "ide" added to it. So, and there isn't really a general rule, but it's usually the first or second syllable, and then "ide." So oxygen becomes oxide, chlorine becomes chloride, sulfur becomes sulfide. You guys follow me there? Okay. So usually, if it's just a nonmetal, then it ends in "id." Okay. If you have a polyatomic ion, then there are other naming rules. Okay, they'll either end in "ate," "ate," or "ite," or they'll have an entirely another name entirely. They'll just have another name entirely. Okay, for example, there's something called, I want this smaller even. For example, cyanide. There's no element named cyanum, or there's no element named that. Right? It's its own thing. It actually is Cn- is the polyatomic ion. Okay, it's the Cn together with the minus charge. That's called cyanide. You won't find that on the periodic table of elements, which is why I have given you guys today, hopefully it popped up in your classroom, a list of ions. Okay, and they have names and what their structures are and their charges, and you aren't expected to build them. You are, however, expected to refer to the ion sheet when you have a polyatomic ion, or when you don't recognize an element name that ends in "ide," you go look at the sheet and you look up what the polyatomic ion is. You're not expected to memorize them. You're expected to be able to use the sheet effectively. All right? Okay. So if we do, let's say, okay, we want to come up with the name of this compound. So if you look at your polyatomic ion notes, I know that we covered what this particular polyatomic ion is, so you can find out what charge it is. Okay, but here's the big sleuth. This is the big detective portion that you guys need to be able to do. Look at your cation. Is this in the first two columns, PB? Okay. It's not in one of the first two columns, so it might be a transition metal. Okay, if it might be a transition metal, okay, then you need to go look at the anion and determine what charge the anion has. So now we look at the anion. This is CO3. In your earlier notes today, you should have found what CO3 is. First of all, what is its name? I know we named it because I looked at your notes. CO3 is, okay, CO3 is carbonate. Carbonate is CO3. What is the charge on our carbonate? No, not on the carbon, on carbonate. It ends in ATE. It's a polyatomic ion. It is a -2. Okay. That -2 is that charge on just the CO3. There are 2 of them here. Yeah? So remember, the subscript outside the parentheses means that there's 2 of whatever is inside the parentheses. They're these separate chunks, right? So this is 2 carbonates. But that means it's a total of what charge? 2 -2s is a total of -4. There's only 1 lead here. 1 cation. One atom. It must have what charge? It must have a +4. Okay. As soon as you get into a +4 or higher, you automatically go to Roman numeral because it doesn't occur normally, or it doesn't occur without a +4 is a tough one to have. So there are no atoms out there that have anything greater than a +3. So this is going to be lead. PB is lead. Roman numeral 4, because that's the charge. Carbonate. You see how that works? Yeah. Questions? No. Okay. That's where we're going to stop.